All right, one of the things that we did today in class was that we were really focused again and on this idea that if I get a trinomial like this as an equation, a quadratic equation, I can identify certain key parts of it. One that I can do is that I can see, so what we did is we first looked at this C value here. When we know that this becomes 0 and this becomes 0, we're left with just this. And anytime our x values are all 0, we're talking about our y-intercepts. So our y-intercept is 3. So I'm going to go up here to 1, 2, 3. There's a point there on my parabola. Another thing we did was we took this equation and we factored it. So we had x plus 3 times x plus 1. In order to get to my x-intercept, that's when y is 0. So my 2 times when that can happen are negative 3 or negative 1. And we're looking again, when does this become 0 and when does that become 0? So here I have negative 3 and I have negative 1. So another big thing we've talked about that our line of symmetry, because we have this beautiful symmetry with parabolas, is that it is going to be directly in between the two x-intercepts, because whatever's on one side is on the other. So we know that the line of symmetry here is x equals negative 2. But that also means that my lowest or highest point is on there too. So I'm going to now take x of negative 2 and I'm going to plug it in. I could plug it into this equation, or I could plug it into my factored form. I'm going to plug it into the factored form just because I think it's easier. But I'd get the same answer. So I have negative 2 plus 3 times negative 2 plus 1. That leaves me with 1 times negative 1 or negative 1. So that means that I also have this point here, this vertex of negative 2, comma, negative 1. So what I'm going to do now is just connect those different points, and that's what my parabola looks like, roughly. It would look a lot nicer if I used GeoGebra instead of by hand. The other thing that we looked at today in class was that if we have something like this, or given a parabola in order to get back to the original equation, we can look for key things, like we can look for our x-intercepts and our y-intercepts. But I'm going to primarily in this slide just focus in on this. So I know I have an x here of negative 2 and an x here of negative 5. That means those are my x-intercepts. That means if I go back to the original equation, I'd have to think about what would turn this to, so that would be negative. So negative 2 would turn something to be 0. So that would be x plus 2, because if I plug the negative 2 in, that would turn that into 0. And the same thing here with the negative 5. This time I'd have to do x plus 5. And if I wanted to, I could simplify it. Y equals x squared by foiling plus 7x plus 10. And I can see that plus 10 right here, which is great. And that's it. What I want to look at with you right now is the first question on the homework, where the farmer has 40 feet of fence. So what we said was that we would have 2 widths and 2 lengths equal to 40 feet. And we said that the width would be x, and it doesn't matter, you could do one or the other. But now to solve for the length in terms of x, we would move the 2w over. We're left with 2l equals 40 minus 2w. And then we'd have to divide everything by 2, so the length is equal to 20 minus w. So if all these here I go by this, I would just make this an x, make this an x, make this an x, make this an x. And so then it would be 20 minus x. So my equation then is y equals my length, because it was the area. So my length now is this, and my width is this. So to get to the area, which I'm going to call y, is I could say would be x times 20 minus x. What's great about this now is you know so much about parabolas is that you know your two x-intercepts here are 0 and 20, because that would turn the whole thing to 0, and that would turn the whole thing to 0. So if I'm 0 here and 20 here, that I know that then my line of symmetry would be when x is equals to 10, which we also said is that means that that's when the width is 10. To figure out what that area would be, I just plug it in. So 10 times 20 minus 10, or 100. So that means if my vertex were here, it would be 10 comma 100. And then it's coming down that way. So it's opening It's like the flip of all the parabolas we've seen so far. Instead of opening up, it's opening down. But this vertex, we talked about this in class too, is really cool because it is the highest point. So this means that this is also the highest area or greatest area that's possible. Everything else is happening twice. You know, like this is happening twice, but it's not the biggest. Or this is happening twice because it's the biggest. But when it happens once, that means it is the vertex. So when I have a length of 10, or when I have a square, my area is going to be maximized with a quadrilateral. Okay, for homework, some of them say things like, you know, find out when it's going to be 84 feet for this one, or when are there going to be this many people sick in another problem. Just concentrate on these pieces, please. Concentrate on writing the equation, setting it up as a quadratic equation that you can see your x-intercepts, and then graph it and just look at what the general meaning is behind the x-intercepts and the y-intercept on the graph. All right, see you tomorrow.